Welcome to Zaption Tour 4.6, Formalizing Relations and Functions. So the essential understanding here is that a function is a special type of a relation in which each value of the domain is paired exactly one value in the range. So there's a lot of words there, so I want to make sure that we understand all of the words in the essential understanding. So here is box 1. It's a bunch of key terms and definitions. A relation is nothing more than a pairing of numbers in one set with a pairing of numbers in another set. Most of the time, we will consider ordered pairs as a relation. So as an example, I could have the relation 2, 3 and 5, 7. It's a collection of ordered pairs. So 2 is paired with 3 and 5 is paired with 7. We call that a relation. The domain is the set of all x values, also known as the inputs. So if I consider this relation up top here, 2, 3 and 5, 7, the domain would be the set of all the x's, so it would just be 2 and 5. The range is the set of all the y values, also known as the outputs. So if I consider my relation up here, 2, 3 and 5, 7, then the outputs would be the set consisting of 3 and 7. Those are just the y values or the outputs. There are two other words in this lesson that we need to make sure we understand, or phrases, and that is the vertical line test, and it is a test to determine whether or not the graph of a relation is a function or not, and we're going to talk about that today. And also the last thing we're going to talk about is something called function notation. Function notation is used to emphasize that the function value depends on the independent variable, and we're going to do some examples of that as well. So lots of words for box number 1. Make sure you have all these words copied down because we're going to refer to them throughout the lesson. Box number 2 is an example. It says identifying functions using a mapping diagram. So what I have here in example A is I have a relation. This whole entire thing is called a relation because it is a collection of ordered pairs. It wants us to use a mapping diagram to illustrate the relation. So what you're going to do is you're going to draw a box, and inside the box you're going to put all the x values. So I have -2, I have 0, I have 4, and then I have 5. So those are all of the x values, -2, 0, 4, and 5. This is going to count as your domain. Okay, then you're going to draw a separate box over here, and inside that box you're going to put all your y's. So I'm going to put 0.5, 2.5, 6.5, and 2.5. So I have 0.5, 2.5, 6.5, and then 2.5 again. But since I already have it, I do not need to write it again. It would be the range. Okay, and the mapping is is the pairing that goes from the domain to the range. So it would be from -2 goes to 0.5. 0 goes to 2.5, 4 goes to 6.5, and 5 goes back to 2.5. So this would be considered a function because each individual member of the domain has a unique output in the range. Even though two numbers go to 2.5, it's still a unique output for every input, meaning that 0 does not go to two places in the range. So this right here represents a function. Here is example B. We'll do the same thing. So over here on the left, I'll use a mapping diagram. I'll put my domain. I'll put all the x values. I have a 6 from here. I have a 4 from right there. I have another 6, but I don't need to put it in there. And then I have a 5. Okay, and then I will put the range over here. Okay, and the range is going to be the number 5, which is this one, the number 3, which comes from here, the number 4, which comes from here, and then the number 8, which comes from here. And now we'll draw a mapping. In this first relation, 6 gets mapped to 5. In this one, 4 gets mapped to 3. In my next one, 6 gets mapped to 4. That's going to be a problem for us. And then our last one, 5 gets mapped to 8. Okay, hopefully you see why this is a problem. 6 is being mapped to two different locations at once. It's going to 5 and to 4. That means that this relation is not not a function, because every element in my domain needs to be paired with exactly one element in my range. Box number 3, this should be a 3, right? Yeah, excuse me guys, apologize for that. This should be in the box number 3. Box number 3 is a U-try. So in this case, I want you to tell me the domain, the range, draw a map, and tell me whether or not it represents a function. Hopefully you got the right answer. If not, here you go. The domain is the set of -1, -2, 4, and 7. The range is the set of 1 to -4 and 7. The mapping would look like this. The domain would have -1, -2, 4, and 7. The range would have 1, 2, -4, and 7. And since each element in the domain is mapped to a unique element in the range, the answer is yes, it is a function. Box number 4 is the vertical line test. Sometimes I call it the VLT for short. It stands for vertical line test. The idea here is that you should be able to draw a vertical line across your graph from left to right, and it should only touch one point at a time. So as you can see in this first example, this would not be a function. The reason is because when the x value is -4, I am touching two values at once. So that would not be a function. However, if you looked over here at the parabola, for any vertical line that you could draw from left to right, you would only intercept one point on the graph at a time. They'd be here, 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 and here. So this one passes the vertical line test, so that must mean that the graph is a function. This one does not pass the vertical line test, so that tells me that that relation is not a function. Okay, here's a U-try. It's got two parts. It says, is the relation a function? Use the vertical line test. So I want you to plot the points on the graph, use the vertical line test, and tell me whether or not they represent a function. Hopefully the right answer you got. A, yes, it does represent a function because it does pass the vertical line test. And B, no, it does not, because it does not pass the vertical line test. At the point 0, you go to 2 and you go to -3 at the same time. Box number 6 is all about function notation. So we need to learn how to say this in algebra. Whenever you see this statement here that I'm highlighting, an F and then a parenthesis and then an X, we say this as f of x. This is called function notation, f of x. So this statement right here is read f of 2. This statement right here is read f of 12. This statement right here is read as f of heart, because that's what it is, f of heart. And this statement right here is read as f of star. So we need to be sure that we can say these words in algebra using function notation. And then the last box, which would be box number 7, because I mislabeled them, would be an example. It says find the range of each function given the domain. So here I have a function, and it is read f of x is equal to 2x minus 7. And I'm supposed to use these individual domain points, these are my domains, to find the range. So I would figure out f of -2 means to take 2 and replace x with -2 minus 7. So the essential idea is whatever this is, those two things have to match. So keep going here. I would get -4 minus 7, which would then give me a value of -11. So for my range, I would have the first point of -11, and -2 would be mapped to -11. So what would f of 1 be? F of 1 would have to be 2 times 1 minus 7, which is just 2 minus 7, which is just -5. So the next element in my range would be -5. And then lastly, f of 0 would have to be 2 times 0 minus 7, which would then give me 0 minus 7, which of course is just negative 7. So the last element in my range would be negative 7. So 1 would be mapped to negative 5, and 0 would be mapped to negative 7.